Hi guys, this is Miss Baker again. Okay, we're going to go over page 203, compare and contrast physical properties and chemical reactions. Okay, physical properties of matter can be observed or measured without changing the composition of matter. Okay, I can look at my dog sitting right next to me and I can say that my dog is black. Okay, that is a physical property of my dog. This means that I can see that he's black. I don't have to change him to see that he's black. Okay, examples of physical properties. The first example we're going to talk about is hardness. It is how difficult it is to scratch something. Okay, if I'm looking at soap and I'm looking at a diamond, which one is going to be harder? The diamond is going to be harder. It would be very, very easy for me to run my finger across the Irish Spring soap and scratch it. Versus a diamond, there is no way I'm going to scratch that diamond with my nail. So the diamond is harder than the Irish Spring soap. Brittleness. It is how easy something is to shatter when dropped or struck. Wood is not very brittle because it will not shatter when dropped, usually. But a wine glass will shatter when dropped. As I drop all glasses and break all glasses, glass is much, much more brittle than wood. That's why in my house I'll have plastic cups instead of glass cups because I drop everything. Elasticity is how much something can bend and return to its original shape. We're looking at a rubber band versus a pencil here. That rubber band, I can twist, I can turn, I can pull, I can stretch it, and it's going to return to its original shape. But this pencil, if I bend it too far, it is going to break. The pencil is not elastic, but the rubber band is elastic. Ductility is the ability of a material to be rolled in a wire. A very ductile material is copper or gold, but I can't very well roll concrete into a wire. Concrete is not ductile, but gold is ductile. Malleability is how easy it is to pound something into thin sheets. Now, the picture I've got here, I believe, is some kind of crystals. These are people standing in there, I believe. But I don't think I would be able to pound this into thin sheets. But again, gold, which is ductile, is also malleable. I think of the word malleable like a mallet. Mallets pound things into thin sheets. That means malleable. Viscosity is how slowly a liquid pours. Molasses is highly viscous. That means it pours very slowly. Water is not very viscous. That means it pours very quickly. Now we look at viscosity in oil on a car. Have you ever noticed your car will require different numbers for oil, like 10W30 or 20W40 or 10W5 or 5W10? That talks about the viscosity of the oil or the thickness of it. At certain times of the year, you want more thicker oil than at other times. I believe it is you want thinner oil in winter and thicker oil in summer. So that is viscosity. Tensile strength is how hard it is to break something. Okay, which is going to be easier to break? This toilet paper or this spider web? Actually, it's much, much, much easier to break toilet paper than spider web. If you had spider webs that were as thick as toilet paper, it would be extremely hard to break. Extremely hard. In fact, the tensile strength of spider webs is stronger than steel if you had the same size material. If you could make spider webs as thick as steel cables. Spider webs are much stronger. It has much more tensile strength. Density is how crowded a material is. It is usually found by mass divided by volume. The higher the density of a liquid, the farther up it will be in a column. Sorry, the farther down it will be in the column. Okay, so if we are looking at this column right here of liquids, this liquid is not very dense, but this liquid is very, very dense, which means this liquid's particles are much tighter together than this liquid's. A state of matter is a physical property, whether it is a solid, a liquid, a gas, or a plasma. Okay, so liquid water, like what you drink, versus an ice cube versus steam. Okay, when you're going from a solid to a liquid, like you're melting an ice cube, you are changing the state of matter, but that is still a physical property. It is still water, whether it is a solid, a liquid, or a gas. So you are changing states, but you are not changing the chemical combinations of it. A solid has definite shape, definite volume, and short, very strong bonds. A liquid has no definite shape. It has definite volume, and it has longer, looser bonds. A gas has no definite volume, no definite shape, and its bonds are broken. Plasma is like a gas, but it has free electrons. The examples are sun, lightning, and neon lights. Heat and temperature are another physical property. Heat is the energy that makes molecules vibrate. The more heat, the more friction, the hotter the object will become. Temperature is the average size of the vibration that the heat causes. The average size of the vibrations is temperature. So something that is warm has lower heat energy than something that is hot. This object is the materials are not going to vibrate as much as this object is. That is the simple difference between heat and temperature. Heat is energy that makes molecules vibrate. This object has lower heat energy than this object. This object has lower heat energy than this object. The more heat, the higher the temperature. How do phases change? Phases change by adding or subtracting heat energy to the molecule. The heat energy shakes the molecule, forcing the bonds to elongate and or break, or allows bonds to shorten and or strengthen. If I've got an ice cube and I add heat energy to it, the molecules are going to vibrate. As that vibration increases, it forces those bonds to lengthen and loosen. Once it lengthens and loosens enough for those bonds to become free, they're still attached, but they can wiggle now, that becomes a liquid. If we add more heat energy to the object, and that heat energy breaks those bonds, that means that it's vibrating so much that it shatters the bonds, it becomes a gas. Now, if I have a gas and I take out the heat energy, meaning I slow the molecules down. When I slow those molecules down, the bonds reattach together and become a liquid. If I continue to slow those vibrations down, those bonds form shorter, stronger bonds, and they become a solid again. So you subtract heat out or you add heat to change the phases. But again, that is still a physical property. Okay, here's another picture of phase changes. From a solid to a liquid, it's called melting. From a liquid to a solid, it's called freezing. If you go from a liquid to a gas, it's called evaporation. When you're going from a gas to a liquid, it's called condensation. If we go from a gas to a solid, it's called a deposition. Sorry, guys. Okay, we also call this snow. If we go from a solid to a gas, it's called sublimation. You can actually take wet clothes and hang them outside on a freezing day and it will dry. That is an example of sublimation. Chemical reactions of matter is the ability of a substance to change into different substances in a chemical reaction. This becomes a different substance and it cannot be reversed. Examples of chemical reactions is the production of an odor. This is like burping. This is like having gas and farting. Okay. This is like the smell of onions. A change in color. A creating a sound like fireworks exploding. Formation of bubbles. Again, burping. Exothermic means a material that gets hot. Endothermic is when a material gets cold because of a chemical reaction. Same thing, exothermic is a chemical reaction. Changes in temperature, which is exothermic and endothermic. When it forms a precipitate, that means when you take two liquids and put them together, and a solid will look like it's snowing out. Okay, what I would like you to do is watch the videos. There are a variety of videos that you are going to go through and watch over the next few slides, and this will show you different chemical reactions. Okay, so when it comes to our assignment, you're going to go to 203 Properties of Matter, the assignment. And the first thing you are going to do is you are going to decide whether the property of matter is a physical property or a chemical property or reaction. So all you've got to do is you've got to grab these options right here and you are going to pull them over to the boxes, whether it is a physical property or it is a chemical property. So you are just going to put it back and forth there. Okay? The second thing you are going to do, after completing the first activity, you need to tell me, define again, what is the physical properties of substances, give me examples, and give me definitions of chemical properties of substances. And then I want you to think about and explain why chemical and physical properties are useful to scientists. The third thing you are going to do is you are going to go to this website. You are going to copy the chemical, Control C. You are going to go to this website. You're going to click here and Control V and push Enter. Okay? You are going to split the screen like this. You're going to pull your activity right like that. Okay? Right. You're going to click on sodium chloride salt. And then you see these numbers right here. Those numbers you are going to find as you go down here. You see these numbers on the left here? You're going to slide down here and you're going to find the 4.21 Okay, here's 4.2. We're going to click here on sodium. And you should be able to find physical descriptions of these things. You should be able to find, let's see, first of all, okay, you're going to say the name, the title, and summary. You're going to find the molecular formula of it. Okay. Then you're going to go to 4.21. You're going to find the physical description of it. Here's the molecular formulas right here. You're going to continue scrolling. Here's what I would do. I would control F and find physical. I would just start typing physical description. You're going to copy this and paste it right here. Okay? Then you're going to find boiling point. So you just got to type boiling. Oops. Okay, so I found boiling point here. So the boiling point is 2,575 degrees Fahrenheit. I'm going to put that here. You're going to continue on all of these options to talk about the physical descriptions of each of these chemicals. Okay? All right, once you are done with that, you are going to go on the internet and you are going to search physical changes and chemical changes. And I would like you to find five other physical changes and 5 other chemical changes. And just click right on in each of these, and you can just type in how you would find if a physical change is happening or a chemical change is happening. Once you're done with all of these, just submit. All right, thanks guys. Have a good